Uh, Hello everyone. Okay. Hello everyone. Welcome to the first Pisoc Presents of this academic year. Before we start with the talk, I kind of want to give some overview, a little bit information about myself, what this talk will cover, some assumptions, and some distinctions. So, a little bit about myself. My name is Svetosław Cenov. I am a second year computer science student here at the University of Bradford. Um, Before that, I studied computer engineering in my hometown of Pravec, Bulgaria. Um, I'm currently the treasurer of Pisoc, and I also work as a part-time software developer for the university, working on a .NET application, but also working with Docker. So my experience at the field and being a student shows me that not a lot of students actually know what Docker is. Um, and the idea of this talk is sort of to present the basic idea of what Docker is, why you should be using it, how to use it, and give you the basic way to navigate with it, to use commands and such. Um, some assumptions before we start the talk. I'm going to assume people actually have some technical background. Um, it doesn't have to be a lot, but I am going to use a lot of terminology. Words like kernel or virtual machine, I might call them VMs, or front end or back end. I would do my best to generalize those terms and, for example, use application instead of back end or front end. But it's good to have that sort of technical background because it will help you understand more about Docker. That being said, you don't really need to have that technical background to follow the talk. It still should be relatively easy to follow, and you still should be able to grasp the fundamentals. Okay, so what's Docker? Docker is, according to the documentation of Docker, Docker is an open source platform for developers to build, run, and share applications. That being said, Docker actually uses standardized units to package your software. These units are called containers, and they're the main feature of Docker. Now, containers are nothing new. They have been around for like more than 10 years now, but when Docker came back in 2013, it sort of looked at containers in a different way and revolutionized the way that they're used. So, the way that Docker works, like I mentioned, you package your own software into a container, and the way that containers are designed, that means that if you set up everything correctly, then your code will be able to execute and run on every device that's running Docker, which in my opinion is pretty amazing. There's that sort of a joke in the software development field where a software developer may have a problem that the application or the feature he developed is working on his machine, but it's not working on the development field. And there's that running joke that that's fine, we're just going to use Docker and ship your machine instead, which is sort of like what Docker does. During the talk, I'm going to tell you why it's not perfectly accurate, but it's still pretty a good idea of what Docker does. So, containers. There are two main things that Docker uses: Docker containers and Docker images. Docker containers, according to the documentation, are a running process that basically executes your code and makes it run in an environment on the host machine that Docker is installed on and the container is running on. So what's a Docker image then? Docker image is an image file that contains all of the dependencies that your code needs to execute, runtime environments, your code, or your binary. And that's pretty much the basic explanation of what Docker containers and Docker images are. You can think of Docker containers sort of like virtual machines. There is a distinction though. For example, Docker containers are running natively on Linux and are Linux based, but that doesn't mean they're restricted to just that. if you have a problem with actually running Linux containers, or for whatever reason you want to change it, Docker provides you with Windows containers as well. But I would advise you not to use those because when configuring and building your own container, some things might be different. So please have a look at that if you're actually going to use Windows containers. So I said that Docker containers are running on Linux. So in that sense, they're sort of like virtual machines. But the distinction is that Docker containers actually run on the kernel of the host machine, where in virtual machines or VMs, they run a guest operating system that your PC or laptop connects to. Here are some of the perks of Docker containers. They are flexible, meaning that no matter how big or complicated your application is, you can still put it in a Docker container extremely easily, as we're going to see later in the talk. They're lightweight, meaning that because they're connected to the host kernel, they use the system requirements in a more efficient way, for example, compared to a virtual machine. They're portable, meaning that once you set up your code and your Docker container correctly, it's going to execute, like I said, on every machine that runs Docker. They're self-sufficient, meaning that each container is its own separate thing. It has its own file system, and it does its own operations without actually communicating to other containers, unless you specify that you actually want to make a cluster of containers work together. They're scalable. It's extremely easy to make replicas of containers and scale them in data centers, for example, and they're secure. A lot of people have a problem with applications actually connecting to their kernel, because you can imagine that a lot of things may go wrong, and if that happens, that's a really bad thing to be like the place to the place for something bad to happen. It should never be your kernel. So Docker is putting aggressive measures for security, meaning that if one container breaks, that's not going to affect your environment, your Docker containers, the other Docker containers, or your PC in any way. So getting started with Docker, I kind of want to run you through the basic commands that you might need to use when using Docker. So here I'm going to open a command line. I already have Docker installed. The easiest way to know that you're actually executing everything right is by typing Docker version. Apparently something went bad with the stream. Sorry. You can type in Docker v, or you can type in Docker / version. What's wrong with it? Okay. Sorry guys, I was having a look at the chat. Thank you for all the support so far. So, running Docker version basically is going to show you that your Docker is pretty much set up. There is another thing that you should probably run when first installing Docker, just to make sure that everything is correct. Like for example, in many programming languages, the first thing you do is to print hello world, and Docker sort of has a similar example in that. So if you type in Docker run, which usually executes a container, and then type hello / world, that's going to look for an image for the hello world container, and if it cannot find it, it's going to pull it from Docker Hub, which we're going to have a look at soon, and execute it. So here we can see it says hello from Docker. This message shows that your installation appears to be working correctly, which is amazing news. Now you're pretty much done, and you can work with Docker. There's no need to set up anything else. So there's a short description of what Docker actually did when you executed that command. So the Docker client contacted the Docker daemon. The Docker daemon pulled the hello world image from Docker Hub, then it executed it, and it streamed the output, which is the whole thing. So, some other commands that I want to show. But before that, I kind of want to introduce you to what Docker Hub is. If you are familiar with programming, you might actually have an idea of what GitHub is, and Docker Hub is something similar. So here I am in my own profile on Docker Hub, and if you click Explore, you'll be able to see the mainstream images that people are downloading and using. So for this example, I'm going to pull the image called Mongo. If you're not familiar with Mongo, Mongo is sort of that non-relational database that me personally, I'm really interested in it. So I decided to do my example with it. So when you open an image, here you're going to see the command docker pull and the name of the image. So we're just going to quickly copy that, go into our command line, and just paste it. So now that what that would do is download that image from Docker Hub, and once it's done downloading, then we can run it. It's going to create its own containers that are actually going to run our own MongoDB database on it. I'm just going to wait for it to download completely. Please keep in mind that while Docker images and containers are pretty lightweight in general, some of them may actually be pretty big in size. Like for example, on my own personal machine, I have Docker containers that are around 2 gigabytes, just because the things packed inside that container are pretty enormous in general. So it's almost done downloading here, and after that I'm going to show you how to execute it, how to check your images, remove images, check running containers, and so on. So the basic Docker commands that you need. And just have a quick look at the chat. Okay, so we're almost done with the Mongo image. Yeah, there we go. So by default, Docker will download the latest version of that image. It's important to know that because sometimes you may want a different version when building a Docker container, but if you don't specify, it's probably going to be the latest version. So now that we have downloaded that image, we can execute docker images, which are going to show the Mongo image that we downloaded and the hello world image. You can see here that we can see their size, when they were created, their image ID, which is important, and the tag, meaning their version. So now what I want to do is execute our own MongoDB database without actually installing or mendling with any MongoDB previously on this PC. So there it is. The way I did it, you can do it in a detached sort of way so that you're not really seeing the output, but right now we are actually in a full-on MongoDB database that it's fully operational and listening on a specific port, and if you want to connect to it with your application, you totally can do that. So let me exit that and show you what Docker PS does. So Docker PS is going to show you all the running containers, what their container ID is, the name of their image, the command that's used to execute them, when they were created, their status, like for example here you can see that that container is still up and running and has been for 38 seconds now, and the ports they are that they're listening on. If you're wondering about that, that's the username of the user that committed that image to Docker Hub. So if you want to stop a container now, you can copy its ID and do docker stop, which will stop that image. Now if we go to docker ps, there's no more images. If we execute docker ps a, that will show us all our previous containers that we're running. So yeah, here we can see them, the hello world container, the Mongo container, their status. Right now they're exited because, well, I stopped the container. And now if you want to remove a container, you can do docker rm and the container ID, which I'm just going to copy. And now if you do docker psa, you can see it's no longer here. So to list our images, we go to docker images, but to delete an image, you go docker rmi, and then let's say we want to delete the hello world image, and it's deleted. That's pretty much it. If, for example, you want to remove the Mongo image, which hasn't been deleted, the container at least hasn't been deleted, you're gonna face some problems. So what Docker is saying here is that you're unable to delete that image because there is still a container who isn't currently running but is still on your system, sort of in that state of being prepared to execute whenever you need it. So in some cases there might be a lot of containers like that. So what you can do is type docker rmi mongo and then force, which is going to force the deletion of the containers and then the image. So now if we go to docker images, it should be empty. Alright, so going back to the presentation, here is a list of the commands. I believe we ran through all of them. This presentation will be made publicly available if anyone's interested. So what and how Docker files? So what exactly is a Docker file? Docker file is that file that you use to build your own container. They're really easy to make. There are some standards that you should follow when making them. I'm just gonna quickly show you how to actually, I'm gonna give you an example of what a Docker file is. Let me just open the Docker file. So here we can see the commands that are executed in that Docker file. Now, a quick disclaimer, you should always name your file Docker file. It's kind of the standard. I'm not really sure if Docker will be able to recognize that file if that's not the name of it. So please, always when creating a Docker file, you only need one. It's a good thing to put it in your main directory of the project, so it has access to everything down the hierarchy. But yeah, please always name your file as Docker file. So some of the commands you might see in Docker files. First of all, from, every Docker file should start with that command. You can have more from commands, but that's sort of the standard. Every Docker command, every Docker file needs at least one. So here we can see that it says from node current slim. This is a Node.js example. If you're not familiar with what Node.js is, it's a framework for JavaScript. If you're interested in making backend applications, I encourage you to have a look at it. So what this does, it's going to pull an image that's the node image, and that's the version of that node image. So tag doesn't specifically need to be latest, or it doesn't specifically need to be a number. After that we have work directory. Now remember I said that Docker containers natively run on Linux. What this will do is create that directory in the Linux environment, which is going to be for our application. Here we copy the package JSON, which is in the repository that I downloaded for this example. Here we can see it. So it's going to copy that package JSON and just copy it in the directory that we made. After that, it's going to run an npm install command in the Linux environment. It's going to expose the container to port 8080, and then it's going to open a command line in that environment and do cmd and then start. So right now we haven't really built that thing. We just have that Docker file, and you can create your Docker files. It's really easily it's really easy to do. Just have a look around at the internet. There's a bunch more commands, but that's honestly the main things you need. So to build your own container from a Docker file, you do docker build, and you can add random, you can add different commands to it. For example, you can do detached or just d, for example. Now that would, what that will do is execute that container in a way that you don't actually see what the container is inputting in your command line. So you can still use your command line freely. We can do so we can do detached, we can do name, which is going to be the name of that container. For example, we're going to do note example. That's going to be the name of the container. And we can do dot. So the dot here means that basically it's going to look in that directory for a Docker file. And if we run this, okay, I'm just gonna do it without the detached tag, because I might actually be mistyping that, but I just want to show you how it works. Okay, then we're not putting a name on it either. Terribly sorry for that. But you could, if you want to, you can have its own name. Okay, I forgot to delete the name. Sorry, guys. So dot, and that is going to build our own container from the Docker file. And here you can command that we saw, the from command here. It's building that. It's gonna follow them in a sequence, and after that, we're going to have a running container and an image that we actually can check with our Docker images command. So you might need to give it some time to build the image. Sometimes it takes a while depending on the example. But that's pretty much the main way to build images. If you want to add more stuff, you can have a look at the tags. For example, some of the stuff in the Docker file, if you don't really need to specify them, you can still do them in the command line while doing the docker build command. While this is executing, I'm just going to open another command line and just switch to that command line instead. Just a second, guys. Okay. So, so this is pretty much how you build a Docker file. After that, I want to run you through what Docker Compose is. Like I mentioned, Docker containers are their own separate thing, and they don't really work together unless you specify. So let's say that I have a backend application that's connecting to the Mongo container that we executed a while back. If I want them both to be in a container so that I can execute them with Docker and just get rid of that bothersome process to opening an IDE, executing my backend and stuff like that, or if I want to share that to someone and make sure it works on their machine, I can put my backend into a Docker file. Like, that's the normal thing to do. but the way if you do it like that, that's not going to work with other containers. So Docker Compose here kind of solves that problem. I'm just going to cd into the example that I have here. So here we have, you can clearly see that we have a Docker file and a Docker Compose YAML file. If we show what's inside the Docker file, here we can, yeah, sorry guys. So inside the Docker file, there are 4 commands. So again, we start with the open command. This is a Java environment, so we're going to work with the Java image. There's an argument command, which makes you create your own sort of a variable. That's, in this case, it's a jar file. And if you don't know what a jar file is, it's sort of like a zip file, but for Java programs. Then we copy that jar file into another jar file that we create in our virtual environment. And then we have an entry point, which is the commands that we use here. You might notice that in the last example, we didn't use anything like entry point or arg for the argument. So what the difference kind of is between entry point and command line is that the entry point will execute those stuff regardless. You can have, for example, you can have an entry point and have CMD at the same time, which is just going to open the command line and sort of execute stuff with different parameters or different commands. They are kind of different. Usually both of them work. Depends on your scenario. You might want to have a look at them. So let me just build this real quick. If we want to add a tag, I'm pretty sure you can just type in /t and just do Java example. Hopefully that should work. Okay, so we're building the image here. You can say again, we're running through the commands, and meanwhile, while that's building, I'm gonna have a look at the other application. Okay. So apparently there was a problem with some of the things that I set up beforehand. I apologize for that. It works perfectly fine on my machine, but here again, the Docker wasn't able to help us. So as you can see, Docker is not really perfect, but it's more of a human error in this case, where I haven't actually set up my files correctly for this demo. Again, terribly sorry for that. But here we can go back to sorry guys, I'm having a trouble connecting to the command line of the first image. Yeah, okay, there we go. So here, as you can see, everything seems to be done pretty much. The image should be ready for execution. So if we go to Docker images, because we didn't specify a tag or anything, we're not actually gonna have that option to run it with the name, but if you can just do Docker run with the image ID, we're going to see that our Node.js server is pretty much done. So here you can see that magic happens on port 8080. So now hopefully, if I have configured this correctly, if we go to localhost 8080, okay, but if we go to localhost 1000, Okay, I'm not actually sure what's the problem here. It should be listening either on port 8080 or port 8000, but apparently it's not. Um, I can't really, well, what I can do now is sort of close that image, make sure that, again, terribly sorry for all of this. I didn't really build the image the correct way, and it's going to be a lot of hassle rebuilding the image. So I'm just going to delete it. And we can force it. Oh, it's okay. So what's saying is that we are actually connected to that image. We're on the local host that we're executing is still connected to that image, but for some reason it's not actually displaying what's in the container. So let me just close the connection to localhost. Well, the last thing I want to show you is what Docker Compose is. So for this, I'm gonna go into the repository that I put. Again, show you that there's a Docker Compose YAML file, and just sort of just show what's inside it. So Docker Compose files are a bit different from normal Docker files. First of all, they're YAML files. If you're interested into YAML in sort of fun file extensions like JSON, YAML, or Tomo, we are going to have a talk about that next week. So what you can see right off the bat is that there's a version. Right now, the last version of Docker Compose should be 3 point something. I'm not really sure, so you can just put 3 and that should work perfectly fine. And then you have services, which is basically the containers that you're going to use in that Docker Compose. Here, for example, I have an app service, which uses the app backend image. The problem with that now is that that image failed to build, but usually you can build your own image, sort of use the image tag here to specify that you want to use that image, to specify that you want it to listen on port 8080, and to depend on database. Now, database, as you can see, is declared below. It uses another image, so it's basically another container, which is the Mongo container, actually. So it's the latest version of that image. It's going to use the latest version of app backend if you don't specify. But we also have volumes. Now, what volumes does is basically everything, every file that is going to be changed or is going to be accessed by the user. For example, like the database, some entries may be added or removed by the user if you're using a backend application or an API, stuff like that. So what you want to do is, in order to record these changes and have them in the database no matter when you execute it, you can just create a volume. So what that's going to do is create a directory for data and just copy the data from the database inside that folder. So no matter if it's stopped or if you rerun that container or that Docker Compose, it's still going to have the same data. You can clean it if you want, that's also an option, but that's not really necessary because it will clean the data, so you have to be mindful of that. And then we give it a specific name, so that's just for ease to, it can be whatever you want. For me it's database container, just to differentiate it from the other one. And you can see that it's listening on port 2017 and 17. So that's pretty much Docker Compose. When you execute the whole thing, for example, type in Docker Compose up. Now that probably wouldn't work because that image is not built. It had a problem with the jar file, which again I apologize for. But if you type in Docker Compose, that's going to execute that whole file, and it's going to run those two containers simultaneously in one environment, so they will be able to communicate with each other. Again, as I said, if one of them breaks, that will not affect in any way the other container, so they can still work as on their own in that environment in Docker Compose. So that's pretty much the basics of Docker. If for some reason you're not really a fan of Docker, if you decided that this demo didn't go well at all and you actually don't want to try Docker or you want to try something else, I would recommend having a look at Podman. It's sort of a company called Red Hat is pushing that. It's made to be way more easier to use, although Docker is not actually hard to use, but I've heard it's more user friendly, and if you have if you just want to be more Linux native, I suppose you can just use Podman. So that was pretty much it for this talk. If you guys have any questions or anything, I'm open to any questions. I'm just gonna be looking at the chat, see what you guys have to say. Again, terribly sorry for the demonstration. I made sure to check it before actually running the stream, but as you can see in this field, everything breaks from time to time. Hopefully that didn't actually change your opinion about Docker, because Docker is actually an amazing piece of software. And if you're interested in software development, you should be you should have a look at Docker, or at least try to work with it, because you can see in the example with Mongo, for example, I was able to execute a full-on database without actually installing anything except Docker. Okay, I'm just gonna wait for your questions. In the meantime, thank you for listening to the talk. It was my first ever Pisoc present. I was really excited for it. And if you have any, if you want to go to more of our talks, we are going to have a talk next week about awesome file extensions, I believe. Our secretary is going to be doing that, and as you saw, there is a Docker Compose YAML file. If you're not really familiar with how the YAML structure goes, you can go to that talk. Hopefully you will enjoy it. Okay, I can see some questions here. So what do you plan to show in the future? Some things we plan to show in the future, like I said, next week is going to be file extensions. The week after that, we plan on doing Git and GitHub, which are extremely important for people that want to get into programming and version control. Some of the other things that we might do, we might present non-relational databases like MongoDB. We might give a presentation on the MVC architecture, if you're familiar with that, sort of the model view controller that web applications use. And we might also have a presentation on Trello. If you want to have a look at that, it's a pretty amazing tool that it's really easy to wrap your hand around. Oh yeah, we might also have a Wi-Fi router hacking demo at some point. Also, for people from the University of Bradford that are have joined the talk, we are doing Capture the Flag competition this weekend, It's sort of that hack the box global event that we enrolled our university into. So if you are interested in hacking, even if you don't have any experience, just join us. It's going to be a great learning experience for all of us, and hopefully we'll all have fun. Right, guys. Well, if there were no more questions, or if you want to get into contact with Pisoc, we have our own webpage, pisoc.net. It's a pretty cool technology. We're using it. We're using Python to run it. We're using sort of a CI to update the website. If you're interested in technology overall, if you want to have a chat, even if it's not technology, even if it's just personal interests, then you're welcome to join our Discord server, which you can find on our webpage. Or if you're a member of the University of Bradford, you can just go to the UBU website and get a membership from there. So thank you all for coming. I'm going to end the stream now. It was a great experience, and yeah, I hope you all enjoyed it.